peeps, it's Julian here from Disrupt Tutoring, and as always, it's such a pleasure to join you. This is question 3 from the DBE Math Paper 2, 2019, and this is going to deal with some analytical geometry. Okay, so they've given us a diagram with various points and values for those points. And in question 3.1, they say determine the midpoint of EC. So EC is, they've given you that point, and C, which is that point. So going straight from the formula sheet, we do know that the midpoint of a line, so this would be 3.1.1, is your midpoint equals basically the average of your two x values. So it's x1 plus x2 over 2, so that's the average, and the same goes for your y, so it's y1 plus y2 over 2. So that formula is straight from your formula sheet, so we're going to fill in some values there. So you can see if our first point is E, so that means x1 is going to be minus 2, and you're going to then plus x2, which comes from your C point, so that'll be 2, all over 2. And your y, the same thing, so your y1 is now 0 from your E coordinate, and your y2 is minus 3. So you're going to add minus 3 all over 2. You can pop both of those in your calculator, but I get obviously minus 2 plus 2 is 0, so that's going to become 0, and your second coordinate will be minus 3 over 2. We're on to 3.1.2. It's now determine the gradient of D, which is this point over here, and C, so DC, which again is that point there. So now we're going to have to use the gradient formula, which is the change in y over the change in x. So 3.1.2 is going to be, as I said, the gradient of DC will then equal the change in y. So the change in y is y2 minus y1 over the change in x, which is x2 minus x1. So filling in the values there, so if D is our first coordinate, it means that y2 is going to be minus 5. And if C is our second coordinate, it means that y1 is going to be minus 3. All over, keep consistent, so whatever you nominated as your y2, your x2 needs to come from the same point. So in this case, it will be from D. So that means we're going to substitute in minus 2. And then minus your x1, which again we need to take from now your C point. So that's going to fill in 2. Put that in your calculator, and you should get minus 2 on the top and a minus 4 at the bottom, so that's going to equal a half. That's your answer for 3.1.2. Okay, and then 3.1.3, you got to calculate the equation of this line AB, which goes all the way up there. So remember, with this type of question, you need to first write down the standard form for a equation of a line. So 3.1.3, and that standard form is y equals mx plus c, where of course m is your gradient, but they've also told us that AB is parallel to DC, and we've just calculated what the gradient of DC is, and when lines are parallel, it means that they have the same gradient. So therefore, we know that m will also equal, or m of AB will also equal a half, and we can state here as the reason that AB B is parallel to BC. Cool. Now we have that y equals a half x plus c. And we've also got this point E, which lies on the line over there, and it's at -2 and 0. So we can substitute that in. So for your y value, we can substitute in 0 from the point E, because you can see there that it's 0, equals a half, and now you can substitute in -2 for your x value, plus 2. Sorry, this is plus c. So we're going to plus c, and therefore now we can calculate what c is. So therefore, putting this in your calculator, we get -1/2 times 2, -2 times 1/2 is 1. Take it to, -1, take it to the other side, becomes 1. So that's some algebra. So therefore, we can conclude that your final answer is y equals a half x plus 1. Yeah, just cleared some writing there to make some space. So we can continue to 3.1.4. and now they ask us to determine the size of theta, which is up here. So in order to do this, we'll first need to calculate what the size of alpha is. And then we're going to use the fact that the exterior angle of a triangle is equal to the sum of the two interior angles. So writing that all down, we're going to have then, so 3.1.4 is to calculate this angle of theta, we're going to have to use another formula that's on our formula sheet. That is tan of alpha should equal the gradient of AB. And remember from the previous question, we calculated that the gradient of AB is a half. So therefore, tan of alpha should equal a half. So then we can do the arctan. So alpha is going to equal the arctan, which is shift tan of a half. Put that in your calculator, and I get it's 26.57. And as I said, so we know the Cartesian plane is always at 90 degrees. So we have 90 degrees there. We have what alpha is. So we can then, as I said, use that theorem. So we can say that theta should equal 90 plus alpha. And you'll just put down the reason is that exterior angles of a triangle, so using a little bit of Euclidean geometry here. So therefore theta equals 90 plus the 26.57. So theta equals 116.57 degrees. Okay, moving on to 3.2, they've now asked us to prove that AB is perpendicular to BC. So in order to do this, one way to prove that lines are perpendicular to each other is to multiply their gradients together, and if their product of two gradients equals -1, it means that those two lines are perpendicular. So basically, and we know that the gradient of AB equals a half from the previous question. So now we need to find out what the gradient of BC is. And now we're also going to need the gradient of BC. But of course, we have C, the coordinates of C, but we don't have the coordinates of B. So how are we going to do that? We do, however, have the equation of AB for line AB from the previous question. So remember, it's y equals a half x plus 1. So we know that AB is y equals a half x plus 1. And of course, we have that there's this point of B is on the x or the y-intercept. So on the y-intercept, we know that x equals 0. So therefore, we can substitute in that y should equal a half times 0 plus 1. And of course, a half times 0 is 0. So y will equal 1. So therefore, the point B is going to be 0 and 1. And then we can then calculate what the gradient of BC is. And again, it's a change in y over the change in x. So y2 minus y1 over x2 minus x1, substituting those values. So if we nominate that B is our first coordinate, we know that the y value for B is 1 minus the y value for C is minus 3 all over, and the x value for B is 0 minus the x value for C, which is 2. So we get here that 1 minus 3 is 4 over minus 2, which becomes minus 2. And then, so basically, the gradient of AB times the gradient of BC will equal, so as I said, gradient of AB is a half times minus 2, which equals minus 1. So therefore, proven that AB is perpendicular to BC. Moving on to 3.3, they've told us that points E, B, C lie on the circumference of a circle. So basically, this point E, B, and C, which means that it can just sketch a rough circle, won't really look that neat, but something like that. So, and then 3.3.1 is asking us then to determine the center of the circle. So we've just shown that AB is perpendicular to BC, which means that they are at 90 degrees to each other. So we can then conclude that if we had to draw a line from E to C, that this is going to be the diameter of the circle that we've constructed. So we can say that angle ABC equals 90 degrees. So therefore the line EC is the diameter of the circle because of the converse. So again, some Euclidean geometry to the theorem that's angle in semicircle. That's the reason. So remember, angles in semicircle is 90 degrees at the circumference of this triangle EBC. Can you see that triangle over there? So what does that mean? If EC is the diameter, it means that the center is the midpoint. And we've already calculated, so remember, so basically midpoints of EC, we've already calculated in the previous question, which was question 3.1.1, which is 0 and negative 3 over 2. So we then say that we know that that's 0 and negative 3 over 2, and that's the center of the circle. And then finally 3.3.2 is to find the equation of the circle in the form of x minus a, which is your x coordinate of the center of a circle, plus y minus b, which is the y coordinate of the center of the circle that we've just calculated. So we need to substitute in those two values from the center of the circle. So we know that x minus 0 squared plus y minus 3 over 2 squared is going to equal your r. And of course we do have lots of points that they've told us lies on this line. So we've got point C, and we've also got point E that lies on the line. So we can substitute in, looks easier to do, point E in for x and y so that we can get r squared. So we sub in E. So we've got then your x coordinate is minus 2 minus 0 squared plus your y coordinate is 0 plus because plus and a minus is a plus, so 3 over 2 squared will equal your r squared. So I'm just going to write r squared on the other side. R squared is going to equal minus 2 squared, which is 4, plus 3 over 2 squared, which will be 9 over 4. And if you put that in your calculator, I get 25 over 4. So therefore, we can now, because we've got r squared, we can now rewrite this entire equation. So this one, so we know that x minus 0 is still x, so it becomes x squared plus, keep your y, and remember it's now plus a 3 over 2 squared, will equal 25 over 4. And that's your final answer. And that concludes question 3. Before I go, I'd just like to say a special thank you to our epic sponsors for making this video possible. You can read all about them in the description below. Remember to visit our website for more videos just like this. If you can't find the answer to the question you have, remember you can always send us your question and we will make a personalized video just for you. And until then, stay epic.